Have you ever found yourself reaching for a snack? Not because you were hungry, but because you were tired, anxious, or simply emotional? You told yourself of just one biscuit. 30 minutes later, the entire packet is gone, and you're left wondering, why do I keep doing this to myself? It's not a lack of willpower. It's not just about food. It's your brain. It's your hormones, and it's by design. In this talk, we'll uncover the hidden circuitry inside your brain that drives emotional eating, cravings, and even food addiction. And, more importantly, we'll talk about what you can do to reclaim control. Because when you understand the biology behind your behavior, you stop blaming yourself and start building real change. Your hunger doesn't start in the stomach. It starts in the brain. Although the physical sensation of emptiness in your belly might feel like the beginning of appetite, it's actually your brain that decides when you're hungry, how much to eat, and when to stop. This process is controlled by a set of finely tuned hormonal messengers that interact with specific regions of the brain, particularly the hypothalamus. When your stomach is empty, it secretes a hormone called Ghrelin. This hormone travels through the bloodstream and enters the brain, where it activates neurons in the hypothalamus to produce the sensation of hunger. The more Ghrelin circulating in your system, the more intense your desire to eat becomes. Ghrelin levels tend to rise before meals and fall after eating. However, what most people don't realize is that these hormonal cycles can be influenced or even disrupted by factors like stress, sleep deprivation, erratic meal timing, and emotional state. On the flip side, your body's fat cells produce another hormone called leptin. Leptin signals fullness or satiety. When your energy stores are adequate, particularly when your fat mass is stable or high, leptin tells your brain that you don't need to eat more. It should be a feedback loop. You eat when Ghrelin is high and stop when leptin signals satiety, but modern lifestyle variables interfere with this balance. Chronic stress, highly processed foods, and insufficient sleep can cause the brain to become leptin resistant, meaning even if your body has enough energy, your brain doesn't receive the stop signal clearly. So, you keep eating. Insulin, the hormone known for controlling blood sugar, also plays a dual role. After you eat carbohydrates, your pancreas releases insulin to shuttle glucose into cells. But insulin also interacts with receptors in the hypothalamus to help regulate appetite. If insulin levels are constantly elevated, which often happens due to frequent snacking or sugary diets, the brain becomes less sensitive to insulin signaling. The result? Impaired appetite regulation, increased cravings, and fat storage. Your nervous system also plays a role. The vagus nerve connects your gut to your brain and sends real-time updates about the state of digestion. But if this connection is blunted, which can happen due to inflammation or chronic stress, the brain receives delayed or distorted information, leading to overeating or undereating. Most importantly, your hunger cues are not fixed. They are learned. If you consistently eat late at night, your body will start releasing ghrelin around that time, even if you don't physically need food. Similarly, skipping meals trains the brain to ignore early hunger cues, often resulting in binge behavior later. This means your eating habits are not only behaviors, they are neurological training sessions. Every time you eat in a certain pattern, you reinforce a hormonal rhythm in your body. And over time, your brain adapts to those rhythms, expecting food at certain times, regardless of physical need. In short, the sensation of hunger is a dialogue between hormones and neurons, and we often mistake it for simple willpower or weakness. When we think about cravings, we often imagine them as fleeting moments of weakness, a sudden urge for chocolate, chips, or fast food that feels irrational yet irresistible. But at the neurobiological level, cravings are anything but random. They are tightly linked to how the brain processes reward, particularly through a neurotransmitter called dopamine. Understanding this system is key to understanding why certain foods, especially those high in sugar, salt, and fat, seem to hijack our behavior and override rational decision-making. Dopamine is not just the pleasure chemical, as it's often called. It's better understood as the neurotransmitter of motivation, reinforcement, and prediction. When you consume something rewarding like a sugary snack, your brain releases dopamine, especially in an area called the nucleus accumbens, a part of the brain's reward circuit. This surge tells the brain, this behavior was valuable, Do it again. Over time, if a behavior is repeated, eating dessert after dinner, reaching for snacks when stressed, the brain begins to predict the reward before the food is even consumed. That's why just smelling freshly baked bread or hearing a snack wrapper can trigger intense cravings. The dopamine response shifts from the reward itself to the cues surrounding it. This predictive mechanism forms the basis of what's known as the EQ-triggered craving loop. Here's how it works. You encounter a cue, a smell, a memory, a time of day. Your brain anticipates the reward. Dopamine is released in advance, and a drive emerges to complete the behavior to satisfy the expectation. The loop is hardwired for survival, originally designed to help humans find and prioritize calorie-dense foods in scarce environments. But in today's world of constant food availability and engineered hyperpalatable snacks, this same circuitry leads to compulsive patterns and loss of control. What's particularly important is that this loop bypasses the rational parts of your brain, like the prefrontal cortex. In moments of craving, the logical voice that says you don't need that is drowned out by a much older system screaming a reward is near. Act now. This is why people often report feeling out of control during episodes of overeating or binging. It's not that they aren't aware. It's that awareness is temporarily overridden by the biochemical urgency of dopamine-driven action. Furthermore, the more you give in to cravings, the stronger these neural pathways become, a phenomenon known as reinforcement learning. Each repetition strengthens the brain's prediction-reward circuitry, making the behavior more automatic and harder to resist over time. But there's a flip side. If you interrupt this loop, by creating friction, delaying action, or substituting the behavior, you start to weaken the connection. The brain gradually learns a new pattern. You're not a failing when you crave something. Your brain is simply doing what it was designed to do: seek reward, minimize effort, and repeat what has felt good before. Cravings are not flaws. They are feedback from a brain that is highly adaptive, but also highly programmable. When the body is under stress, whether from psychological pressure, emotional turmoil, or even physical exhaustion, it activates a powerful hormonal cascade known as the stress response. At the center of this response is the hormone cortisol, produced by the adrenal glands and regulated by a brain structure called the hypothalamic pituitary adrenal HPA axis. Cortisol plays an essential role in survival. It mobilizes energy, sharpens attention, and helps the body respond to threats. But when stress becomes chronic, under acute stress, cortisol initially suppresses appetite. This is why in dangerous or high-pressure moments, like public speaking or emergencies, people often don't feel hungry. However, once the immediate threat is gone and the system begins to recover, cortisol remains elevated for hours, sometimes even days. And this is when it begins to increase appetite, specifically for high-calorie, high-sugar foods. The body believes it needs to replenish energy lost during the stressor, even if the stress was emotional rather than physical. This is a biological leftover from evolutionary times when stress meant danger and physical exertion. But modern stress is different. It's not a predator or a lack of shelter. It's deadlines, social tension, financial uncertainty, or internal emotional pressure. These types of stress don't require physical energy output, but they still trigger the same hormonal machinery. As cortisol remains elevated, the body seeks energy-rich comfort foods, not out of hunger, but as a coping mechanism. These foods, when consumed, blunt the stress response temporarily by triggering the brain's reward centers. Sugar and fat provide quick dopamine hits, making us feel momentarily safe and soothed. This pattern, stress right arrow cortisol, right arrow cravings, right arrow reward, creates a reinforcing loop that can lead to emotional eating and even long-term dysregulation of hunger and fullness cues. Over time, the brain begins to associate stress with eating, not as nourishment, but as regulation. This can become an automatic behavior. You feel tense, you reach for food. You feel lonely, you open the fridge. The food becomes less about fuel and more about managing internal discomfort. Adding to this, cortisol has a suppressive effect on the prefrontal cortex, the region responsible for decision-making, impulse control, and self-awareness. In moments of stress, this part of the brain is downregulated, while the amygdala, the brain's threat detector, becomes more active. This means your capacity to pause, reflect, and choose wisely is literally reduced in stressful moments, you're not imagining it. Stress actually makes it harder to say no. Sleep deprivation compounds this issue. Poor sleep raises cortisol baseline levels, increases ghrelin, hunger hormone, and decreases leptin, satiety hormone, creating a hormonal environment primed for overeating. When combined with daily stressors, this creates the perfect storm for impulsive, emotion-driven eating. Emotion-driven eating. This is not a question of weakness or lack of discipline. It's neurobiology. Understanding that your food choices are often the downstream effect of your hormonal and emotional environment, not simply a failure of willpower, is the first step to breaking the cycle. The human brain is remarkably adaptable. This capacity for change, known as neuroplasticity, is the reason we can form habits, unlearn destructive behaviors, and even rewire deeply rooted emotional responses. When it comes to eating behavior, neuroplasticity plays a crucial role in both the development of disordered patterns and the creation of healthier ones. The same circuits that reinforced impulsive food choices can, over time, be redirected toward regulation, awareness, and balance if we engage the right protocols consistently. One of the most powerful principles in neuroplasticity is that neurons that fire together wire together. If you consistently eat while scrolling your phone, watching TV, or in an emotional state, the brain links these actions. You build a network where food equals comfort, distraction, or reward. The good news is that if you change the input, the output eventually shifts. If you start introducing structure, attention, and intentionality into your eating routine, the brain begins building new circuits to support those behaviors. The first step is stabilization. When your brain doesn't know when or what kind of energy it will receive, it stays in a state of low-grade survival stress. That's why consistent, predictable eating patterns, such as eating every 4 or 5 hours with adequate protein and fiber, begin to retrain the hypothalamus and related regions to regulate hunger hormones like ghrelin and leptin in a smoother, more anticipatory way. This is not just meal planning. This is signaling safety to the brain. Second, incorporating tools that calm the nervous system can drastically improve food-related decision-making. When cortisol is high, your prefrontal cortex, the rational, self-aware part of your brain, is impaired. Simple practices like non-sleep deep rest, NSDR, yoga nidra, or even slow diaphragmatic breathing for 5-10 minutes before meals can reduce the stress reactivity and allow the executive brain to remain online. You eat not from anxiety, but from awareness. Another effective rewiring tool is habit substitution. The brain doesn't erase habits, it replaces them. If you often snack late at night as a way to unwind, trying to suppress the urge rarely works. Instead, pair that same time of night with a different dopamine-releasing activity. A walk, journaling, stretching, listening to calming audio. Over time, the brain rewires the association between that time and a new, healthier habit. Tracking is also powerful. Not calorie counting in a rigid way, but reflective tracking. For example, writing down what you ate, how you felt before, and how you felt after. This activates the prefrontal cortex and brings metacognition, thinking about thinking. Into the process, you start to see your patterns. You bring the subconscious into consciousness. That alone begins the process of change. Lastly, celebrate small wins. The dopamine system thrives on completion and reward. Finishing a balanced meal, pausing before a craving, or going one day without emotional eating. These moments are not insignificant. They send signals to your brain that you're safe, you're learning, and you're adapting. And when those signals are repeated, they become the foundation of a new neural reality. You are not broken. Your cravings, your habits, even your struggles with food, they are not flaws in character. They are reflections of a highly adaptive brain doing exactly what it was wired to do: survive, seek reward, and reduce discomfort. But the same brain that learns those patterns can unlearn them, can reshape them, and can rebuild healthier circuits through deliberate action, consistency, and compassion. Remember, this is not a quick fix, it's a biological process. Neuroplasticity requires repetition. Your hormones need rhythm. Your brain needs safety. So start small. One mindful meal, one breath before a bite, and one walk instead of a binge. Because those small choices repeated daily are the building blocks of lasting change. If this video gave you a deeper understanding of your own biology, hit like, leave a comment, and subscribe to MindForge. Your brain is always listening. Let's train it. Together.